I'll briefly describe a simulation that models flow around the sphere at low Reynolds number. And the idea is that we are looking at the velocity vectors, and the simulation allows you to pick different fluids and allows you with this slider to change the velocity. It then calculates the Reynolds number for each condition, and the important thing to notice is as the Reynolds number increases, you get region downstream where velocity vectors are in the opposite direction. You get these vortices. This affects, of course, the drag on the sphere. So we'll look at the simulation and see how they change as we change the velocity. So here's the simulation, and this is for honey, fairly viscous at low Reynolds number, and then as we increase the Reynolds number, you start to see these vortices form, and they get bigger at the higher Reynolds number. If we switch to water, even at the relatively low Reynolds number, we're seeing this behavior, and then it increases at high Reynolds number. And of course, this affects what the drag is on the sphere in the flow.